June 1944, Western Pacific, north of the Mariana Islands. The sky was a hard, metallic blue as the first wave of Japanese carrier aircraft swept eastward, engines humming in tight formation. Their pilots scanned the horizon, confident in their speed, their training, and their long-held belief that American radios were crude, unreliable tools, childish devices compared to the discipline of visual signaling. Many still joke that U.S. pilots flew with toy radios, cluttering their cockpits with unnecessary noise. But that morning, something felt wrong. Static crackled through Japanese headsets, garbled, faint, unpredictable. Messages dissolved in the wind. Formations drifted apart. A squadron leader tried to rally his pilots, only to hear half his flight vanish into silence. Below them, invisible to the Japanese eye, American radar stations aboard multiple carriers tracked every incoming aircraft with precision. Fighter directors issued crisp instructions across clear, stable U.S. radio channels. Dozens of American pilots banked sharply into position, each movement guided by a voice hundreds of miles away, yet impossibly accurate. The Japanese pilots, unaware that coordinated interceptors were already climbing toward them, continued forward, assuming their enemy remained as disorganized as before. They did not yet understand that the toy radios they mocked were about to reshape the battle unfolding beneath their wings. And in moments, the realization would strike with devastating clarity. In the early years of the Pacific War, Japanese aviators carried themselves with a confidence forged in the skies over China and Southeast Asia. Their training was rigorous, their aircraft agile, their combat record impressive. They viewed American pilots with a mixture of contempt and curiosity. Brave, certainly, but inexperienced and reliant on technology rather than instinct. Nothing symbolized this perception more strongly than the American fixation on aircraft radios. Japanese fighter doctrine placed minimal emphasis on radio communication. Many of their early war aircraft were equipped with radios that transmitted only intermittently or failed outright under the stresses of combat. Pilots relied on hand signals, pre-arranged maneuvers, and visual cues rather than spoken commands. Even when radios were installed, they were often removed to save weight or because pilots mistrusted them. The Imperial Japanese Navy believed that a skilled aviator should not depend on electronic devices to maintain formation or strike targets. By contrast, the United States entered the war with a different philosophy. American doctrine treated communication as a tactical multiplier, something that allowed pilots, ships, and ground stations to act with shared awareness. Pre-war exercises demonstrated that coordinated radio use could turn scattered aircraft into a unified striking force. Even so, early U.S. radios were far from perfect. Pilots complained about static, limited range, and interference. But unlike the Japanese, they saw these devices not as burdens, but as tools that would improve with time, industry, and refinement. That refinement arrived quickly. By 1942, new radio models such as the SCR 522 and later VHF systems offered clearer transmission, greater reliability, and better resistance to background noise. American engineers prioritized durability, designing radios that functioned in humidity, salt air, and sudden altitude changes. Meanwhile, the U.S. Navy worked to integrate radio communications with emerging radar technology, a revolution in its own right. Fighter direction officers aboard carriers learned to track incoming threats and vector interceptors into optimal attack positions. This partnership between radar and radio would soon transform aerial warfare in the Pacific. The Japanese, however, did not anticipate the scale of this change. Their pilots continued to view American radios as unsophisticated devices that cluttered dashboards and encouraged laziness. They believed discipline and visual cohesion were superior to commands relayed through static-filled headsets. Yet beneath this confidence lay growing problems. Aging equipment, reduced production quality, and the inability to maintain reliable communication across large formations. American commanders recognized this weakness. Reports from early battles over the Coral Sea and Midway suggested that Japanese units often fractured in flight due to radio failures. Pilots lost contact, misinterpreted signals, or simply never received warnings about incoming American fighters. These gaps created opportunities that the U.S. exploited with increasing skill. By the time the Solomon Islands campaign began in mid-1942, the difference in communication philosophy became increasingly visible. American squadrons operating from Guadalcanal relied heavily on radio guidance from improvised radar stations on shore. Though crude at first, these stations enabled U.S. fighters to intercept incoming Japanese raids at much higher success rates than earlier in the war. For Japanese pilots, accustomed to fast-paced strikes and coordinated formations, the sudden appearance of American interceptors in perfect position seemed uncanny. The Japanese misinterpreted these events as coincidence or luck. Few realized the degree to which American signals, those same toy radios they mocked, were becoming the backbone of Allied air power. As 1943 progressed, U.S. communication networks expanded dramatically. New radar towers rose on Pacific Islands. Carrier task forces learned to synchronize their fighter screens over vast distances. American aircraft received improved radios with standardized frequencies, enabling seamless coordination across squadrons and between air and sea. This widening technological gap set the stage for a dramatic confrontation, one in which Japanese overconfidence and American innovation would collide with irreversible consequences. It would not take long before the Japanese pilots flying into battle discovered that the radios they dismissed had quietly become one of the most decisive weapons of the war. By late 1942 and into 1943, the Pacific battlefield had evolved into a proving ground for communications technology. Nowhere was this clearer than the Solomon Islands and New Guinea campaigns, where Allied forces steadily expanded their network of radar stations, signal units, and airfield communication centers. What began as a handful of fragile and improvised installations soon grew into a layered detection system capable of tracking enemy aircraft hundreds of miles from target areas. The American advantage was no longer theoretical, it was becoming operational. On Guadalcanal, for instance, the early SC and SCR-270 radar sets provided advance warning of Japanese raids long before visual spotters could detect them. Though sometimes plagued with mechanical issues, these sets gave American commanders something Japan lacked: time. Time to launch fighters, time to coordinate positions, time to intercept with precision rather than desperation. These intercepts were only possible because the radios in American aircraft could relay detailed instructions from ground-based fighter directors directly to pilots in the air. Japanese aviators found themselves increasingly confused by the way American fighters appeared at precisely the right altitude and vector. During the first months of the Guadalcanal campaign, Japanese Zero pilots assumed U.S. aircraft were patrolling randomly and stumbling into position. But the pattern became too consistent to ignore. American fighters, F-45 Wildcats, later the F-40U Corsair and P-38 Lightning, were no longer reacting. They were waiting, positioned, informed. Japanese pilots, meanwhile, continued to experience chronic communication failures. Many aircraft had unreliable receivers and even worse transmitters. Pilots often entered combat with radios that barely functioned at all. When they attempted long-range missions over the vast distances of the South Pacific, formation leaders frequently lost contact with their trailing planes. Sections drifted apart. Wingmen misinterpreted hand signals or never saw them at all amidst cloud cover or sun glare. The consequence was fragmentation. Japanese attacks arrived at targets in scattered groups rather than cohesive waves. Escorts failed to synchronize with dive bombers or torpedo units. And when American fighters intercepted these fractured formations, the results were devastating. American commanders noticed these vulnerabilities quickly. Reports from pilots and radar operators noted that Japanese formations often became disorganized long before reaching U.S. positions. Intelligence analysts concluded that poor communication discipline combined with inferior radio equipment played a central role in these breakdowns. This assessment encouraged even greater investment in Allied communication technology.
The U.S. Navy responded with improved radios such as the AN/ARC series, offering clearer channels and resistance to interference. Carrier air groups integrated standardized signal procedures across squadrons. Fighter direction officers aboard carriers refined their craft, turning radar plots into real-time instructions that guided American fighters into ideal attack positions. The concept of centralized control of dispersed forces, something radio technology made possible, became a fundamental part of American doctrine. This doctrine matured throughout 1943 and into 1944. During the operations around Bougainville and the Bismarck Sea, U.S. fighter controllers demonstrated extraordinary precision, vectoring interceptors with timing measured in seconds. These engagements revealed a stark contrast. Japanese pilots often entered battle unaware of American fighter positions, while U.S. pilots rarely flew blind. They had eyes, radar eyes, extending far beyond the horizon, and radios carried.
For much of the early Pacific War, aerial engagements between Japan and the United States followed a pattern shaped by the limits of visual detection. Japanese formations relied heavily on leader-led maneuvers. A squadron moved as its commander moved. A dive or turn depended on hand signals or assumption. This method had worked well during the war's opening months, when Japanese pilots held superior training and experience. But as the conflict intensified and American tactics evolved, this approach revealed critical vulnerabilities. U.S. fighter pilots, equipped with increasingly reliable radios, were no longer dependent on what they could see. They received instructions from radar controllers miles away, enabling them to bypass the chaos of visual-only communication. When dispatched to intercept a raid, American fighters did not waste time searching for the enemy. They flew to exact coordinates, altitudes, and angles provided by radar-guided fighter direction. This difference reshaped air combat. Instead of reacting to Japanese attacks, U.S. fighters positioned themselves ahead of time, forcing the Japanese into defensive maneuvers. Rather than entering battle in scattered groups, American pilots converged simultaneously, creating a wall of interception that struck with precision. Japanese pilots struggled to respond. Without reliable radio contact, they could not easily regroup when surprised. Their formations broke apart under pressure, and once cohesion was lost, individual pilots were left to face coordinated American attacks alone. The tactical shift was unmistakable. Communication, not speed, not maneuverability, had become the deciding factor in the air. And as American confidence grew, the technological gap widened further. Behind every successful American interception was the product of intense engineering effort. Radios such as the SCR-522, SCR-542, and later VHF models were designed not merely for communication, but for resilience. Engineers understood that pilots needed equipment that could endure humidity, vibration, rapid temperature changes, and the electromagnetic clutter of a busy battlefield. The result was a series of radios that, while not flawless, consistently outperformed Japanese counterparts. The true breakthrough came when these radios were integrated with radar systems. Fighter direction officers aboard carriers and island bases used radar screens to track both enemy formations and their own aircraft. Every contact was plotted, updated, and relayed to pilots in real time. Combined with reliable radios, this created a dynamic flow of information that turned American squadrons into aerial extensions of the radar rooms guiding them. Japanese aircraft, in contrast, often lacked functioning transmitters or receivers. Their radios were notorious for limited range, poor clarity, and susceptibility to interference. Pilots sometimes launched into combat with equipment that worked only intermittently or not at all. In long-range missions extending hundreds of miles over open ocean, this deficiency proved catastrophic. The gap grew wider as American carriers standardized frequencies and protocols across air groups. Pilots trained extensively in radio discipline, learning to communicate concisely under pressure. Japanese forces lacking comparable training and equipment could not match this level of airborne coordination. Technology did not merely support American tactics, it enabled an entirely new style of warfare. On the Japanese side, the experience of facing radio-directed American forces was often disorienting. Pilots who once dominated the skies found themselves encountering U.S. fighters in situations that defied expectation. They were intercepted earlier, at higher altitudes, from angles they never anticipated. Many attributed these encounters to luck or improved American scouting, not realizing the full extent of the communication network working against them. Reports recovered after the war reveal repeated complaints from Japanese aviators about radio failures. Some pilots described flying long stretches without hearing their commander's voice. Others recounted receiving partial transmissions drowned in static. During large operations, entire squadrons sometimes broke apart unknowingly, scattered across the sky before reaching enemy airspace. This lack of communication bred confusion in critical moments. When American fighters appeared unexpectedly, Japanese pilots could not call for reinforcements, warn their comrades, or reorganize their formations. What began as tactical surprise quickly became strategic collapse. Some Japanese pilots eventually recognized that American interceptors were being guided by something more sophisticated than visual scouting. Yet the depth of the American communication system remained largely unknown to them. Many underestimated its scope until it was too late. As the war progressed, Japanese aviators increasingly entered combat with a sense of uncertainty, aware that their enemy could see across vast distances while they flew half-blind. Their frustration and confusion would soon reach a climax in the skies over the Philippine Sea, where the limits of Japanese communication collided with the full maturity of American radio-directed warfare. While pilots executed the missions, it was the commanders and fighter direction officers who transformed radio technology into a decisive strategic asset. In the U.S. Navy, figures such as Admiral Raymond Spruance and Admiral Mark Mitcher understood that communication was not simply a support function, it was the backbone of an entirely new form of naval aviation warfare. Aboard American carriers, Combat Information Centers, CICs, became the nerve centers of fleet operations. Inside these dimly lit rooms, radar operators tracked enemy aircraft at ranges unimaginable only a few years earlier. Fighter direction officers translated these plots into precise intercept instructions, issuing calm, measured commands to pilots thousands of feet above the ocean. Bearings, altitude changes, vector headings, each instruction sharpened the effectiveness of U.S. fighters. This system allowed American commanders to coordinate multiple squadrons simultaneously across vast stretches of the Pacific. When enemy raids approached, fighters from different carriers could be placed into layered defensive positions, creating a seamless aerial shield. During offensive strikes, radios ensured that dive bombers, torpedo bombers, and escorts arrived at target zones in disciplined waves. Japanese commanders lacked comparable capabilities. With no integrated radar network and unreliable radio communication, they could not control their formations once airborne. Commanders often launched entire air groups with only general mission instructions, leaving pilots to coordinate among themselves with whatever limited communication they could manage. This contrast in command presence, from structured, informed leadership on the American side to fractured, disconnected direction on the Japanese side, played a decisive role in shaping the outcomes of key battles. And the human dimension of this difference echoed intensely through every cockpit. For American pilots, radios were more than equipment, they were reassurance. A steady voice from a carrier or ground station reminded them they were never alone, even when flying deep into enemy territory. This sense of connection lifted morale, reduced uncertainty, and allowed pilots to make bolder tactical decisions. If a formation needed to regroup, they adapted instantly. If an enemy flight emerged unexpectedly, warnings traveled at the speed of speech. The psychological benefit was immense. Pilots trusted the system because it consistently worked. They entered combat knowing their movements were part of a coordinated plan, reinforced by information from radars and fellow squadrons. Japanese pilots lived a very different reality. Silence often dominated their missions. Many launched with radios that faltered shortly after takeoff. Others dealt with static so overwhelming that messages became undistinguishable from ocean wind. When combat erupted, pilots could not call for help or reorganize formations. They confronted American ambushes without fair warning and watched their companions break away into isolation without the ability to regroup. This isolation took a profound toll. Veteran pilots felt mounting frustration, younger trainees felt fear. The knowledge that American pilots communicated seamlessly made the situation worse, amplifying the psychological divide between the two air forces. In modern warfare, psychology is inseparable from technology, and in the Pacific skies, communication defined the mental battlefield as much as the physical one. On an operational scale, the U.S. ability to synchronize forces through radio communication reshaped entire campaigns. During the island-hopping operations of 1943 to 1944, American commanders orchestrated multi-branch assaults involving naval gunfire, carrier aviation, land-based bombers, and amphibious forces. Radios linked these elements into a unified fighting machine. In contrast, Japanese operational planning remained fragmented. Without reliable airborne communication, Japanese carriers could not coordinate their formations once airborne. Commanders often launched entire air groups with only general mission instructions, leaving pilots to coordinate among themselves with whatever limited communication they could manage. This contrast in command presence, from structured, informed leadership on the American side to fractured, disconnected direction on the Japanese side, played a decisive role in shaping the outcomes of key battles.
June 19, 1944, the Battle of the Philippine Sea. The morning sun climbed over the vast Pacific, illuminating the massive fleet formations of both sides. For Japan, this day represented a final attempt to halt the American advance toward the Mariana Islands. Mobilizing what remained of their once-feared carrier air arm, the Imperial Japanese Navy launched a series of long-range strikes, waves of bombers and fighters intended to smash the U.S. invasion fleet and buy time for defensive reinforcements. But from the first minutes of the battle, the gulf between the two air forces became unmistakable. American radar stations aboard the carriers USS Enterprise, USS Lexington, USS Yorktown, and others detected the incoming Japanese raid more than 150 miles away, far beyond visual sight, far beyond what Japanese pilots believed possible. Inside each carrier's combat information center, operators plotted the enemy's position and fed continuous updates to fighter direction officers. The Americans listened. The Japanese did not. From those CIC rooms, calm voices echoed through the headsets of dozens of pilots preparing on the flight decks. Coordinates, altitude, bearing, closing speed. Each update sharpened their intercept approach. The launch barriers dropped. Hellcat fighters roared down the decks and into the sky, climbing into formation with geometric precision. Meanwhile, aboard the Japanese carriers, flight leaders struggled to maintain cohesion as their formations stretched thin across the ocean. Radios crackled with partial fragments, broken syllables, clipped transmissions, static-laden call signs. Some aircraft lost contact entirely before they had even traveled halfway to the American fleet. Pilots attempted hand signals, but sprawling distances and cloud cover rendered such efforts useless. As the first Japanese wave approached the interception zone, the U.S. advantage became overwhelming. American fighter controllers vectored 2 full squadrons directly into the enemy's path. The U.S. pilots received real-time updates as the Japanese changed altitude or loosened formation. And when the moment came, American fighters rolled into their dives with absolute confidence that their timing was perfect. It was. For Japanese pilots, the attack felt sudden and inexplicable. American fighters did not appear gradually. They appeared all at once, from above, from the side, from angles too precise to be coincidence. Some Japanese aviators never saw their attackers at all.
Others described seeing Hellcats descend in coordinated waves, striking multiple parts of their formation simultaneously. Their instinct was to call for regrouping or defensive maneuvers, but when they pressed their radio triggers, silence greeted them. Or worse, garbled fragments of unrelated transmissions they couldn't decipher. This was the moment where years of communication disparity revealed their brutal consequence. What Japanese aviators endured was not just a tactical disadvantage, it was the sensation of entering a battle blind. American pilots, by contrast, remained in constant communication. Break left, climb 200, enemy rolling out south. Each message tightened the weave of their intercept pattern. Each instruction flowed from radar screens that saw every Japanese movement minutes before visual contact. As the sky erupted into burning trails and plummeting debris, Japanese leaders tried desperately to reorganize their squadrons. But navigation errors and broken radio links scattered their groups even farther apart. Some bombers drifted miles off course. Fighter escorts unable to maintain radio contact became separated from the strike elements they were supposed to protect. For the Japanese pilots who survived the initial American assault, a terrible realization settled in. The U.S. fighters were not lucky, and this was no mere ambush. Their enemy possessed a coordinated, technologically advanced network that Japan could neither detect nor disrupt. And from that moment onward, the tide of the battle and the wider Pacific Air War shifted irreversibly. As the first Japanese strike group disintegrated under American interception, the magnitude of the communication gap became undeniable, not just to the Americans observing radar screens, but to the Japanese aviators fighting for their lives in the open sky. Yet 3 more waves were already en route, each facing the same invisible advantage that had shattered the first. Back aboard the American carriers, fighter direction officers worked with quiet precision. Every movement of the Japanese formations was tracked. Every adjustment in altitude or heading appeared on their radar scopes. With radios functioning clearly from ship to aircraft, they orchestrated the defense like a conductor leading a symphony. Squadrons that had just returned from combat were rearmed, refueled, and launched again with remarkable efficiency, guided into fresh vectors within minutes. Meanwhile, American pilots already in the air received updated bearings as new Japanese waves approached. No pilot was left guessing, not about the enemy's distance, not about their altitude, not about where to strike next. The second Japanese wave encountered this fully synchronized system head-on. American fighters intercepted them nearly 70 miles from the fleet. Radios buzzed with short, unbroken commands. Japanese pilots, by contrast, again struggled under failing communication. One Japanese bomber leader attempted to correct his formation after spotting American fighters, but his wingmen never heard the call. Some maintained course, others veered away instinctively, and a few drifted downward into cloud banks. When the Hellcats attacked, there was no cohesion left to defend. Wave after wave met the same fate. The third Japanese wave attempted to approach at a lower altitude, hoping to exploit a blind spot in the radar coverage. But American picket destroyers and supporting carriers detected them anyway, feeding new vectors to the fighter direction teams. Once again, Hellcats rose into perfect intercept positions, an impossibility without the communication network that linked every aircraft to every ship. By the time the fourth wave attempted its run, the Japanese air groups were exhausted, scattered, and demoralized. Some pilots managed to stay in formation, but their radios failed in the critical moments of approach. Coordinates were misunderstood, escorts drifted apart, bombers descended towards false targets. A handful who broke through the outer defenses found the American fleet shrouded in anti-aircraft flak directed by advanced fire control radar. The results were catastrophic. In Japanese after-action reports, surviving pilots described a sense of being hunted by an enemy they couldn't fully see or predict. One officer wrote that American fighters seemed to materialize from the air, while another noted that U.S. interceptors always appeared exactly where we feared they might be. These impressions were not illusions. They were the real consequences of a system that merged radar detection, signal clarity, and rapid communication into a seamless defensive shield. American pilots, meanwhile, felt the opposite sensation. Clarity, control, connection. They rarely entered combat with a full understanding of enemy positions. When one squadron expended its fuel or ammunition, another seamlessly took its place, directed by continuous radio updates. The sky to them was mapped and narrated, and this confidence translated directly into combat effectiveness. The outcome of the day became known to history as the Great Marianas Turkey Shoot. More than 300 Japanese aircraft were shot down. American losses were minimal. The Japanese Navy lost the bulk of its trained carrier aviators, men whose experience could not be replaced. The integrity of Japan's carrier air power collapsed almost overnight. This was not simply a defeat in numbers, it was a defeat in capability. The radios the Japanese dismissed as American gadgets or clumsy toys had become one of the most decisive elements of the entire battle. Without them, American fighters would have struggled to engage at distance, coordinate relief cycles, or respond to rapid changes in enemy movement. With them, the U.S. Navy fought with a unity and precision unmatched in the Pacific. By the end of the battle, Japan's ability to wage offensive carrier warfare had effectively ended. And all across the Pacific, commanders understood that communication, not just firepower, had turned the tide. The devastation of the Philippine Sea rippled outward long after the smoke cleared from the horizon. In a single day, Japan had lost not only hundreds of aircraft, but also the irreplaceable core of its trained naval aviators. These losses reached far deeper than the immediate destruction of machinery. They severed Japan's ability to coordinate complex carrier operations for the rest of the war. And at the center of that collapse was the same overlooked factor that had shaped the battle: communication. American intelligence teams aboard the carriers began collecting pilot reports within hours of the engagement. The pattern was unmistakable. Nearly every U.S. squadron credited clear radio communication as the decisive element that allowed them to intercept the Japanese so early and so accurately. Fighter direction officers highlighted the seamless handoffs between radar operators and airborne pilots. Squadron leaders emphasized how real-time updates allowed them to reorganize, conserve fuel, and strike with precision. The U.S. Navy quickly recognized that this victory represented more than superior tactics or aircraft. It was a triumph of an integrated communication system working exactly as intended. Meanwhile, Japanese commanders attempted to reconstruct what had gone wrong. Pilots who survived described missions where silence dominated their headsets, where messages dissolved into static, and where formations stretched apart across the ocean before ever sighting the enemy. Many expressed disbelief at how American fighters consistently arrived at the perfect altitude and bearing. A few suspected advanced radar integration, but most attributed their defeat to unexpected enemy coordination.
The destruction of Japanese carrier aviation at the Philippine Sea marked more than the loss of aircraft and pilots. It exposed structural weaknesses that Japan could no longer overcome. In the immediate months that followed, the Imperial Japanese Navy struggled to reconstitute its air groups, but the shortage of trained aviators, spare parts, and reliable communication equipment made recovery impossible. The carriers themselves remained afloat, but without skilled air crews and functioning radios, they were carriers in name only. The battle had revealed a truth Japan could not reverse. Without communication, no amount of courage or aeronautical skill could prevail in modern aerial warfare. American commanders understood their shifting advantage. Reports from Admiral Spruance's staff emphasized that the seamless integration of radar, radios, and fighter direction was now the doctrinal core of Pacific air operations. Carrier groups reorganized to maximize this strength. Radar picket destroyers were positioned farther ahead of the fleet. Air search radars increased in number and sophistication. Fighter direction teams grew in size and capability, refining the techniques that had turned the Philippine Sea into a decisive triumph. Meanwhile, U.S. pilots continued to train under a communication-centered philosophy. Simulated intercept exercises drilled them in rapid, concise radio discipline. Squadrons learned to trust the unseen guidance from CIC rooms deep within their carriers. This synergy between pilots who executed and officers who directed became one of the most powerful operational tools in the American arsenal. It reduced guesswork, amplified situational awareness, and allowed U.S. forces to project coordinated air power across a theater larger than continental Europe. For the Japanese, post-battle analysis painted a bleak picture. Their air groups suffered irreparable losses not only in combat but in operational cohesion. Many pilots had flown into battle without knowledge of American radar capabilities. Others had relied on compromised radios or sporadic transmissions that failed under pressure. Internal reviews acknowledged that the empire lacked the industrial capacity to mass-produce reliable communication equipment at the scale required to compete with the United States. Factories strained under material shortages. Training programs were shortened drastically to replace lost aviators, leaving little time to practice radio coordination. These limitations were reflected starkly during the later campaigns of 1944 and 1945. At Leyte Gulf, Japanese air attacks often struck in fragmented waves, lacking the integrated timing needed to overwhelm American defenses. During the Okinawa campaign, radar-directed American fighters intercepted kamikaze units far from the fleet, reducing their effectiveness. Even suicide attacks, Japan's final, desperate tactic, were hampered by inconsistent communication between pilots and ground controllers. American forces, by contrast, expanded their communication network across newly captured islands. Radar stations rose on Saipan, Tinian, and Guam, each linked to U.S. carrier groups and land-based fighters. These installations formed a vast detection grid that covered thousands of miles. Every approaching aircraft, friendly or enemy, appeared on American scopes, and every intercept could be directed with precision. The final months of the war showcased this advantage to its fullest extent. While Japanese aircraft fought bravely, they did so blind. While American pilots faced danger, they faced it informed. And in modern warfare, information often decides who survives the encounter. The aftermath of the Philippine Sea, therefore, was not simply the end of Japanese carrier aviation. It was the emergence of a new understanding that radios, radar, and the flow of signals between them had become the true lifeblood of air power. This transformation reshaped strategies, determined outcomes, and marked the transition from early war improvisation to late war mastery. It also set the stage for the broader reflection on why communication, once dismissed as trivial, became one of the most decisive elements in the Pacific War. In the long arc of the Pacific War, many weapons drew attention: aircraft, carriers, torpedoes, artillery. Yet one of the most decisive instruments was something far less visible: the steady, disciplined flow of information carried through American radio headsets. What Japanese pilots once dismissed as trivial, even childish, revealed itself to be the heartbeat of a coordinated fighting force. It was not the loudest weapon, nor the most dramatic, but it shaped the outcome of battles with a quiet, relentless precision. The story of America's wartime radios is not a tale of technological perfection. Early models failed often. Pilots complained. Engineers improvised. But the United States treated communication as a foundation, not an accessory, and invested the industrial, scientific, and organizational effort needed to transform crude devices into dependable tools of war. By the middle years of the conflict, those tools allowed American forces to fight as a unified organism, seeing beyond the horizon and striking with synchronized purpose. For Japanese aviators, the silence inside their cockpits became a metaphor for the wider struggle. Their courage never wavered, but courage could not compensate for isolation. Cut off from leaders, separated from wingmen, and unable to receive timely commands, they battled not only American fighters, but also the unforgiving physics of distance and the harsh limits of their own equipment. The gulf between the two air forces was not merely technical, it was philosophical. One embraced communication as a strategic necessity, the other treated it as a secondary concern until it was too late. In the end, the battles over the Pacific taught a lesson as enduring as any fought with steel or fire. Victory belongs not only to those who strike hardest, but to those who understand, coordinate, and connect their forces with clarity. The radios once mocked by Japan's finest pilots became symbols of a new era of warfare, an era where information shared in an instant could turn the tide of an entire campaign.